analysis of the three methods of classification. In the previous lecture, we saw three different methods which were used for classification. So in this lecture, we are going to have an analysis of that. Basically, our idea is to understand when to use each method. To be clear of that, we are having this lecture separately. Okay. So what was our first approach? In the first approach, we first found the class conditional densities P of x given Ck. Then we from x given Ck, we also used it to find the marginal density, which is P of x. Then we found the posterior P of Ck given x. Okay, how did you find posterior? From base theorem, P of x given Ck into P of x, P of Ck whole divided by P of x. See why I'm repeating this in every lecture, because these are very basic and important concepts. So it's good that it gets stamped in your mind. Okay. So you find this posterior and then you find the final class using decision theory. And in this, another advantage is that you will get to know the joint distribution P of x Ck, and you will also get to know the marginal distribution, which is P of x. So we already discussed that this is the most difficult approach. The difficulty is because it involves finding one is joint distribution, which is over both x and Ck. And when I say joint distribution, finding it with a good accuracy takes good amount of efforts, right? So see, let's say your input x is of very high dimension. Let's say the dimensionality of x is very high. So you will need very huge amount of training data to find the class conditional probability itself. Like if you want to find this class conditional probability P of x given Ck, if your x is of high dimensionality, simply finding this class conditional probability will take a lot of training data. So this is it takes a lot of training data, because you want to at least find it with some reasonable accuracy. There is no point in simply saying I found this. You have to find it with good accuracy. So it will take good amount of data. That is the first thing. And P of Ck prior, this you can estimate from the data itself. So that's not a big issue. The advantage that you get from this model is this marginal density. As we discussed in last class, this can be determined, the marginal density, and using this marginal density, you can detect new data point. That is why these are called as generative models. Okay. And greatest use of this model is, see, what I would advise you is, if you want to do a simple classification problem, you want to classify it into some classes C1, C2, C3, do not use this first approach, because unwantedly you are wasting your time, you are putting extra energy, you are using extra data. Use your other methods. Approach second was good for that. But use this particular method in two cases. One is if you want to do outlier detection. What is outlier detection, or it is also called as novelty detection? That is detecting a new data point which have low probability under the model, or you can say prediction can be of low accuracy for such points. So detecting outliers is one thing for which you can use this model. That is, if you want to, let's say, generate new point, especially because you get the distribution of the input P of x, you got the distribution of input. So if you want to generate some new point, that is one area where your approach 1 will be helpful for you. So either if there is any reason why you need this joint distribution, or you want to find marginal density, then only you choose this model, because then you don't just do the classification, you will get these advantages as well. Second thing, this is what I would say you can always use for classification, because this has some good depth, because you are finding the posterior P of Ck given x. Find the posterior, and from that you are using decision theory in order to find the final class C1, C2 or C3. So because you have posterior, you are getting a lot of information, which we'll discuss in the coming lectures, which you need for classification and also for getting some understanding of the whole model. So having posterior is a big plus. And moreover, if it is just for the classification purpose, you can use this model. That is finding joint distribution P of x Ck. It will be a waste of time if you just want to do classification. So don't do this using the first approach. You simply do the second approach, in which you find the posterior. From posterior, you use decision theory and find the corresponding class. Okay. So here you are directly getting the posterior. This is the second approach. And when to use the third approach? See, with the third approach, we already discussed you have an input x, you are making the model. What will the model do? It will find f of x, a function which will simply mark it to class C1, C2, C3. So here the greatest problem is you have no idea of probabilities at all. You don't know posterior, you don't know anything. You just know there is one x which is mapped to class C1, C2, C3. You don't know with what probability, what accuracy. You have no idea whatsoever. So this is not a model that I would recommend. But the thing is, if you want to make a simple model, and this model only uses to simply identify classes, and let's say you don't need exact idea of what is the accuracy of what probabilities you have, then you can go for this model. And here, what you're doing is a discriminant function. And let us just understand how the decision boundary will be made. Let us say this is the graph. In this graph, this is x, and this is, here you have the probability, you can mark posterior. So what internally happens is automatically, let's say this is p of c1 given x. We have used this graph in some sort of a previous lecture. Let's say this is p of c2 given x. So what this approach will do is it will simply give you this decision boundary. This is the decision boundary. So this model will tell you, I'll simply make a decision boundary which will tell you that whatever comes to the right of the decision boundary belongs to class C2. Whatever is in the left of decision boundary, all those values of x belong to class C1. All the values of x which are right of this decision boundary class belong to class C2. But it won't tell you what are the probabilities, what are the posterior or anything. So if you simply want this decision boundary, if you simply want the idea about classes, then you can use this third approach. So second approach is the best for all the classification approaches. Use third if you want a very simple approach and simply want classification. Use first approach if you want complete idea of whatever is going on. You want complete probabilities. You want to maybe generate inputs. Those cases, go for first approach. For easiness, go for third approach. Generally, go for the second approach.